What is going on, guys? Welcome to this Python tutorial series for data science. In today's video, we're going to talk about NumPy even more. We're getting into NumPy functions today. In the last video, we talked about NumPy attributes, how to create arrays, what arrays are, why they're useful, why NumPy is useful in general. In today's video, we're getting into some functions, some different functions. We have shape manipulation functions, we have aggregate functions, we have all kinds of different NumPy functions that we can apply to our arrays. And as I said, this is the topic of today's video, so let us get into the code. So the first category of functions that we're going to talk about are the mathematical functions. And mathematical functions are functions that we just apply on our array, and they perform a mathematical function or operation on all of the individual elements. So let's import numpy as np and create a new array, np.array. And let's say we have, I don't know, 1, 2, 3. Again, a 3 by 3 matrix, 4, 5, 6, and 7, 8, 9. Now, what we can now do, and I think we did this in the last video already, we can apply mathematical functions to that array. So we can now choose one function of the NumPy function stack, and we can just apply to it. So, for example, print np dot, and now we can choose the function, for example, sign. I think this is the one we used in the last video, np.sign a. So this would apply the sign function on all of these individual values and return a matrix of the same shape with the different values, or with the results as the individual values. So let's run this. And you'll see I'll get an array full of the results of the sign function. Of course, I can do the same with cosine. So np.cosine, and I would get the cosine. And I think I can also do this with the with the, how was it called in English? I don't know the name, but the tan function, sorry. And we can also do this with different functions, for example, exponentiation. So this would be e to the power of a. So e to the power of 1, e to the power of 2. As you can see, this is e itself. Then we have e to the power of 2, e to the power of 3, and so on. So we have these different functions here, and we also have the square root, of course. Square root is very simple, just the square root of each number, np.sqrt. So we get the square root of 1 is 1, the square root of 2 is this, it's a very famous number, the square root of 4 is 2, and so on. So we just pick the square root of each number. And last but not least, we have the logarithmic function. So the logarithm of a would be the logarithm of each individual number. So the next category of functions that we're going to talk about are the so-called aggregate functions. And these functions give us a key statistic of our matrix, or from our matrix. So for example, what I can do is I can just print a.sum. This would be an aggregate function, and it would give me the sum of all the individual elements. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. And in this case, this is 45. And of course, this works no matter how big the array is. So even if it's a, I don't know, 20-dimensional array with 1,000 entries, we get the sum of all the individual elements. And of course, we also have the max function. So we get the highest value in the matrix, in this case 9, of course. And with the min function, we get the minimum value or the lowest value. So 1 in this case. As you can see, it's not hard to tell. But we also have some more statistical values, for example, the mean. So the arithmetic mean, which is just all these numbers summed up divided by the amount of numbers. So the sum over 9 in this case. And this is 5, of course, because 45 over 9 is 5. And this is the function we get the mean with. Also, we have the median function. So, but this is a function used in a very different way. So np.median. We don't use it, we don't call this function directly from our array, so we don't say a.median, we say mp.median, and then we pass the array. And then it gives us the value which is right in the middle, in this case, of course, 5. So for those of you who don't know what the median is, it is, for example, let's say we have these values here. The median is always the value in the middle. I think this one right here, 4 to the right, 4 to the left. Yeah, the median is the value in the middle, and if you have an odd number of values, of course in a sorted list, if we have an odd number of values, we add the 2 and divide them by 2. So we would have, in this case, 1.5. And this is what a median basically does. And the last thing that we need to talk about, or the last aggregate function, is the standard deviation. So again, called with the Numpy module or from the Numpy module. And the standard deviation is basically how much does a value or each value deviate from the mean of the array. So if we have the mean of 5, it was, how much on average are the values, or how much on average is each value deviating from that mean? And this is also a very important statistical value. So the next category that we're going to talk about are the so-called shape manipulation functions. And these functions manipulate the shape of our array, obviously. And in this case, we have a 3 by 3 matrix, and we're going to extend that because 9 is not a good number to work with. When it comes to reshaping, we're just going to add one value at the end of each row, because now we have a 3 by 4 matrix, and this is in sum 12 elements. And 12 is a very good number to reshape because, you know, it's 2 times 6, 6 times 2, 3 times 4, 4 times 3, and so on. So we have all these very nice values. And what we can do now is we can just say a equals a dot reshape. This is the first function, the reshape function. And here I can just pass a tuple of a shape. So for example, 2 times 6, because 2 times 6 is still 12. You need to stay in, you need to keep the same number of elements, because here you have 12 elements. And the product of these two numbers here, of course, should be the same amount of elements, so that we can reshape it, because we're not adding, we're not removing values, we're just reshaping the existing values. In this case, instead of 3 by 4, we say 2 times 6, which is perfectly fine. So let's look at the results. And you can see that it produces a 2 by 6 array. Of course, I can do this the other way around, 6 by 2. And it works. Now let's try something else. For example, I can say 5 times 5. And you'll see that I get a value error because I cannot reshape an array of size 12 into the shape 5, 5, because these would be 25 elements. I could try, though, to reshape it into a 3-dimensional array. For example, I could say 2 times 3, which would be 6 times 2. So 2 times 3 times 2 is still 12. And this would work perfectly fine because we're keeping the same amount of values. So this is the basic reshape function. Yeah. Other very interesting functions are, for example, the flatten function. So if I flatten an array, I get a one-dimensional version of this array. So let's say print a dot flatten. And when I do this, I get a one-dimensional list, just basically a simple array of all these values in a row. So basic functions, sometimes we need that because sometimes when we work with neural networks later on, we have a flattened input layer, and or actually it does it for us. So I don't know if we need this with a flattened input layer, but this is definitely something that we might need. And I've used this in machine learning projects already, so it's not very, it's not useless. That's what I'm saying. Another function that is very important is the transpose function. The transpose function just swaps the shape of the array. So for example, in this case, we have 3 by 4. And if I say print a dot transpose, I would get a 4 by 3 array, as you can see. So it basically turns around the whole array. So yeah, it basically transposes it. It swaps the dimensions, as you can see. So this is the basic transpose method. And another thing that I want to show you here is the flat iterator. It's not a function, but it's an iterator. So what we can do here is we can, for example, just say for x in a dot flat. And flat, as I said, is not a function, but it's basically the flattened version of this array, and we can iterate it. So I can just say x, for example, print x, and it will print all the values. Or I can also just print a.flat index 7, for example. So it's the same as using the flatten function, but it's just an attribute, so it returns to us the flattened version of our array. With the next category, we're now going to talk about how to join arrays together. So if we have two arrays like here, I created a new one, we can join them together into a new array, especially when they have the same shape. So we have two 3x4 matrices here, and we can now join them together into one array. And how do we do that? We can use different functions for that. So let's say C equals NP, and one function would be concatenate. So this function would join these two arrays together on an existing axis. So in this first array, so to say. So let's pass a tuple of A and B. And when I run this, you're going to see nothing because, of course, I have to print it. I always forget the printing part. As you can see, it now basically combined them by stacking them on top of each other. So we have the first 3 rows and then the other 3 rows from the B array. And of course, we can also use another function. So let's say C2 equals np.stack. This is another way of joining them together. But in this version, we're joining them together on a new axis. So instead of using what we already have and joining them together within that main array here or within that main dimension here, we create another dimension. So I'm just going to show you what I mean. So let's print C again, and let's print C2. And you're going to see the difference is that this here is C stacked in one list, and this here is C2, where we have an additional list for the individual array. So they are combined in one array, but separated because of the shape. So we can also just print the shape here to see the difference, because stack basically creates a new dimension. As you can see, we have 6x4 because we have 3 plus 3, but we stay with the 4 values. And here we have basically two lists or two separate 3x4 matrices. This is the difference between stack and concatenate. But we can also use another function or two other functions, namely vstack and hstack. So if you want to stack horizontally, we can use hstack, and if you want to stack vertically, we can use vstack. So let's see how this looks. C2. Horizontal stacking works if they have the exact same dimensions, and it looks like this. So we basically add, we go a step further and we add them right together. So we have the first row here of the A array combined with the first row of the B array, which is now the first row of the C array, or the C2 array in this case. So this is horizontal stacking, and I can also use vertical stacking. This would be just on top of each other, as we already know it from the concatenate function. Now, of course, what we can also do is the opposite of joining, which would be splitting. And to split an array in Numpy, I just say np.split, specify the array and also the number of equal parts I want to split this array into. So in this case, I changed this here to be a 4x4 matrix, and I could split this in 4 equal parts. And when I do this, you'll see the result is 4 different arrays. So we have 4 individual arrays for each row 1. So array 1 would be the first row here. Then we would have the second row, the third row, the fourth row. And we split this array into 4 equal parts. And I can also do this with 2. So I can decide to split it into 2 equal parts. And then I would get one array with the first 2 rows and one array with the last 2 rows. So of course, what I cannot do is split this into 3 equal parts because we have 4 rows and 4 is not divisible by 3. So we get a value error that says array split does not result in an equal division. So this does not work. What I can do though is I can choose the horizontal axis. So I can say np.hsplit, which would be the opposite of hstack. And you'll see that it splits it like that on a horizontal axis. So you see 1, 2, 4, 5, 7, 8, 8, 5. is the first array, so basically the first two columns, and these are the last two columns. Now, last category of functions that we're going to look at are adding values or adding lists into our array. So we have this array here, and what we want to do is we want to add a new row here, 10, 20, 30, 30, 40, but we don't want to do this like that. We want to do it with code, and we have b being a simple Python list, and we can now append this list, or we want to now append this list into our array. So what I do is I say a equals np.append a, and I want to append b, but when I run this, you're going to notice that this doesn't work. So I'm going to print a. It doesn't give us any errors, but you will see that it doesn't work because the dimensions are not the same. And the problem is that it has to flatten out the array so that it can append these values to it. Of course, this is not what we want. We want to do this in a different way. We want to have this row put here on the end. And to do that, what we have to do is we need to surround b with square brackets, because we need to have the same dimensions here. Here we have a list. We have one dimension here. We have a list, and in this list we have 4 lists. And what we're doing here is we're just adding a list. To have the same thing, to have the same dimensions here, we would need to have a list in a list, so that I have the same format and I can put b into a. I hope this is somewhat understandable. And when I run this, you'll also probably see that it doesn't work, because we have to choose an axis first. We have to say, okay, on what axis am I going to add these? And we're going to choose axis 0, so it will add a new row. As you can see, it works. Now, this is one way to do that. Another way would be to insert b into a. So we have a second function here. Let's delete this one here. A equals np.insert. I want to insert a, or onto a. Into a, I want to insert b. And I want to do this on, or actually I think I have to first specify the index here. So I want to say 1, and then I want to add b, or insert b into a. And I'm going to choose axis 0, but I think I'll have to, no, actually I don't have to add any brackets to b. So as you can see, what I do here is I say np insert, I take the array a, specify the index 1, which is actually the row 1 because we're on axis 0, and then I'm inserting the values of b. So I have one new row here. Of course, I can also choose index 2, which would be row 3. As you can see, it works. And here what I can do is I can also say axis 1, and this would then add it column-wise. So it would take these values and add them in a new column and not in a new row. So that was the episode about NumPy functions. You now know different types of NumPy functions. You know how to join arrays, how to split arrays, how to perform mathematical operations or mathematical functions, or use mathematical functions on the arrays. You know how to use aggregate functions, how to reshape your arrays. So you learned a lot of things in today's video about NumPy. Practice the material, don't forget it. Keep watching the series. We're getting deeper and deeper into the material. And yeah, that's the video for today. Thank you very much for watching. Hit the like button if you liked the video. Feel free to ask questions and give feedback in the comment section down below. Of course, subscribe to this channel if you want to see more. And thank you very much for watching. See you in the next video. Bye.